Welcome back to our Puredata tutorial. So in last exercise, we tried to take a look of the pixel information which contain the red, green, and blue color information for a particular pixel we record from the video web camera. And in this week, we tried to make use or interpret this color information and to compare a predefined color information we store in the RGB information, and based on the comparison we can distinguish whether there are some changes in front of that particular camera corresponding to that single pixel on the screen. And by make use of that comparison, we can detect, for example, whether there are some movement or some change in the appearance of that particular location in front of the camera. So what we are going to do is we try to, for example, in the last exercise, we obtain the color information red, green, and blue over here in the three number boxes. And to recall, we can have a look of what we have done so far. So basically, we create a screen of full screen video with the whole webcam image on top of the jam window. And make use of the metro box we periodically to sample the color information at a particular point from the webcam image. So that particular point we can control by using the slider in this way. So we put the X and Y more or less in the center of this slider, which corresponding to around the center position of the screen. And when we can, for example, to hold a piece of color paper in front of that particular position. So in that case, that color information will be sampled from the Pythagorean command, and I'll use it to change, for example, the color of the rectangle in the center of the screen. So once you are happy about this particular color information, you can stop the metro. Once you stop the metro, the number over here, red, green, blue, will be stored as that particular piece of color information of the, for example, color paper. You put it in front of the camera. So we continue from this particular position. So based on this number, we introduce three more number boxes. And I'm going to use these three number boxes to store or to maintain the color information of this one, the red, green, and blue. And after that, I try to compare the two color instant, the one which capture from the live information and the other one which is stored right there. So I'll put in the number over here in the run mode. And then the green information. So I manually key in the color information right here. So in later exercise, we try to make use of some automatic facility in order to store the color information in those number boxes. So once we have two sets of number boxes, the one we store and the other one was supposed to be captured from the live image. And then the next one is we try to make use of a comparison. And this comparison is actually a subpatch or an abstraction I have already written beforehand. So I call the name color change, which will detect the color change between the two instances, the one which is captured from the live image and the other one which is maintained and kept beforehand. So what we are going to do is we try to connect all those color information to the first one, second one, and the third one. The first one comes from one set of color image, which I need to do the pack again. So I pack the three number, red, green, and blue, into one single list of RGB information. For this one, it seems a little bit redundant in a sense that I did an unpack and then it changed from one list into three numbers, and then I do the pack again to convert the three number into one list again. So actually you can connect the line directly from the output from the pix data to the color change. But for this one, I would like to, for example, to observe the individual numbers, such that I will try to put the three individual number right here for the monitoring of the color information. And for the second one, I also use the pack. With the red, green, and blue information, and connect to the second inlet. For the last one, it's a number. You can use either a number or a slider in order to control, which I use to indicate the threshold. So that means I'll try to compare these two sets of RGB information and to see whether the difference between them is less than this number. If it's less than this number, so the number is more or less, the color is more or less the same. So it's greater than this number, that means there's a significant color change in the same position within the capture screen. So the output is a toggle, which I would like to indicate whether there's a change in the color at that particular pixel. And for the color change object, is actually we call an abstraction. So in run mode, when you click upon this abstraction or subpatch, we will pop up this particular patch which I have written beforehand. So it's looked a little bit complicated, and basically it's come with three inlets. The first one I put in the order. This is the first one, the second one, and the last one. The first one will be unpacked into three numbers, the $1, 2, and 3. And the second one will also again will be unpacked into three numbers, the red, green, and blue. And the 6 numbers will be fed or sent out to this particular complicated expression. So the EXPR is actually the short form of expression. So you can use a very complicated mathematical calculation within an expression. For this one, I use this particular variable which indicate which particular number you send from the inlet. For example, $F1 is the first one, and $F4 is the fourth one. So basically, this particular formula is calculate the distance between these two sets of color information. The first one, 1, 2, 3, is similar to a point in a three-dimensional space like the X, Y, Z, although we use the RGB to indicate. And the second set is actually again a point in a three-dimensional space, X, Y, Z, which is at this point indicated by the red, green, and blue information. So the $F1, $F2, and $F3 will be the first point in the color space, and $F4, $F5, and $F6 will be the second point in the color space. So what I use is the Pythagorean theorem in order to calculate we call the Euclidean distance between the first point and the second point. If we take a look from those information, for example, from Wikipedia, we learned from secondary school that the length of this line and also the length of this line of a right angle triangle, we can actually come up with the formula like this one. The square of this one plus the square of this one is actually the square of this one. So in order to compute the distance between 2 points in the space, for example A and B, we can convert it into a right angle triangle and then make use of the sum of the square of this line and the sum of the square of this line, and then take the square root. We can come up with the length between A and B. So either in two-dimensional space, that is in a plane, we can make use of this formula, or even in three-dimensional space, we can extend it into similar version. So for example, in two-dimensional space, we will use something like this one, the x1 minus x2 square plus y1 minus y2 square, and then we take the square root to calculate the distance. And then in n-dimensional space or three-dimensional space, we can generalize into x, y, z, and in our case, we generalize into R, G, and B. So the operation of this one is we take the Pythagorean theorems and measure the distance between the 2 points in the three-dimensional space by using the square root and square of the difference between x, y, and z. And then after we make the comparison, we try to compare that distance with the number we send from the third inlet. If this is greater than that particular number, we'll send out 1. So 1 as a result will indicate there's a change in the color information. If it is 0 without a cross, so that means the colors are more or less the same. So we can experiment with this one. So in this case, we measure the more or less the center part of the screen, and then we use the color paper as a way to indicate whether there's some change in the color information. Another thing we may need to pay attention is this particular number. So at this point it's 0, so it doesn't make sense. So we'll convert it, for example, to a larger number to have a look. Once we start out with the color comparison, we can observe, for example, the change in those colors. So in that case, if we do not observe any change in the toggle box, we may need to adjust, for example, the range of this number. We can put it into a smaller one. When we put it into a smaller one, we observe that it comes with a cross. And we can use the color piece of information to have a look. So in this case, if, for example, the original color of this piece of paper match those stored in the second set of the RGB information, after they did the calculation, the difference between the two color information is less than 1. So we do not have the cross as the output from the color change patch. So if I take away this piece of paper, and at this point it will sample the color from the background, and the background color is significantly different from the original color of this particular book. So we can observe the change in the toggle box under the color change patch. So for this one is of similar color, and then if I take it away, the color change significantly. The color box, the toggle box right here, turn immediately into a cross, which indicate a 1 over here. So this is the way we try to interpret any color change in front of the camera at a particular pixel point. So for this one, you can observe it's a little bit more clumsy in the sense that we need to, in the very beginning, observe this particular number, and then we manually type in the number in the second set of RGB information, and then we will do again to observe the light changes and to observe this particular toggle box. And in that case, we will try to improve it by, for example, some automatically mean how we can store the number over here without typing it by our hands. And then the other things remaining is how we can interpret this change from 0 to 1 or 1 to 0 in order to effect some of the image output or audio output or whatever interactive content you would try to manipulate. So this is the objective of this sequence of exercise.